There are 5 properties of logarithms that you should know. These are the first 3. Log base a of x plus log base a of y can be rewritten as a single logarithm, log base a of, you multiply what's in your parentheses. X times y is xy. So if you add 2 logarithms together, you can multiply what's inside their parentheses and write it as a single logarithm. Same idea, log base a of x minus log base a of y. This time, if you want to write it as a single logarithm, instead of multiplying, divide. X divided by y. The negative log piece goes in the denominator. All right, and then last one, it's already written as a single logarithm, but if you have any kind of coefficient or number in front of your logarithm like this, x times log base a of y, you can bring that x inside your parentheses as an exponent. So this is log base a of y to the x power. Whenever you start with multiple logarithms or with a coefficient and rewrite it as a single logarithm or without a coefficient, it's called condensing. So if you go from the left side to the right side, you're condensing or writing it as a single logarithm. Whenever you start here with a single logarithm and move all of your exponents out or split it apart into multiple logs, it's called expanding. And side note, in order for you to use this property, these bases here must be the exact same number. In this class, that's always going to be the case, so you won't really have to worry about that rule. Okay, I have 5 examples of this. Your directions are usually going to be to condense, but you may also see it as express as a single logarithm. So we'll start basic. Log base 2 of 5 plus log base 2 of 6. This is 2 logarithms being added together. I can write it as one single logarithm. And because I'm adding here, you multiply the 5 and the 6 together. And because you can actually multiply 5 times 6, it's silly to leave it separated like that. So 5 times 6 is 30. All right, let's do some that are not just using one property. Or why would you ever use that third property? The reason you use this third property that deals with exponents is because you have to get rid of any coefficients before you can combine and use these first 2 properties here. So when we're condensing, get rid of your coefficients first by moving them in as exponents, and then you can combine your logarithms. So when condensing, deal with your coefficients, that is the number in front of your logs, before writing as one single logarithm. Okay, so if I bring that 3 inside, it's only brought into this x here. 3 natural log of x minus natural log of 4. I like to write my natural logs in cursive because it helps me keep it straight that it's an L and not an I. You're welcome to write them however you want. Anyhow, if I bring that 3 inside, it's only going to go with the x. So I'm cubing the x, and the 4 stays as is. And now I can use the second property here that says when you subtract your logs, you can write it as a single logarithm, and you would divide your arguments, is what you call what's written in your parentheses. So the minus sign means the 4 goes in the denominator. I'll write that in the next example. No. Okay, the minus sign means you put it in the denominator. All right, let's do one that's a little more difficult. Same idea though, we have to deal with our coefficients before we can write it as one log. So I need to bring this 3 inside as an exponent, this 9 inside as an exponent, and this 5 inside as an exponent. Just the number, you don't have to worry about bringing the sign inside. So this would be rewritten log base 7 of x cubed plus log base 7 of y to the 9th power minus log base 7 of z to the 5th power. I can combine all three of these into one logarithm in one step. You just have to remember minus means denominator. So this piece here has a minus in front of it, so it is going in the denominator. Everything else stays on top of your fraction. Log base 7, the x cubed, there's not a minus sign in front, so x cubed stays on top. Y to the 9th, there's not a minus sign in front, so y to the 9th stays on top. Z to the 5th, there is a minus sign on top, so it goes in the denominator. And I skipped an example from what's in the notes. It doesn't matter what order you have everything written in. This could be a positive. Actually, let's change it from what's in the notes. This could be a positive. It just matters that the minus piece, this is going to go in the denominator. The minus piece goes in the denominator. Everything else stays on top. So I just changed this problem from what is in the notes, but we can still work through it. Just like before, deal with your coefficients first. Nothing there to worry about. My 1/3 comes in here. My 2 comes in here. So this can be rewritten log base 5 of x minus log base 5 of y to the 1/3 power plus log base 5 of z squared. Now rewrite it as one single logarithm. Log base 5, anything with a plus sign in front of it, or anything that doesn't have a negative. If there's not a negative, it's implied to be a positive. So any positives go on top. Y to the 1/3 has a minus in front of the log, so it goes in the denominator. Z squared has a plus in front of it because we changed this problem from our notes, so z squared stayed on top. This is how Alex, your homework system, wants your answer. But just as a side note, let me write that in blue up here. If I have a fractional exponent like this, usually you rewrite it as a square root, and this denominator here becomes your index, and your a, the numerator, stays as your exponent. So your homework allows this to be your answer, which means I will allow that on your test as well. But just know that generally you would rewrite this as, instead of to the 1/3 power, you would write it as the cubed root. You can have a 1 there if you want. So this one is usually considered more correct, but they're both correct according to your homework. Let's do one last example. If you plan to take calculus, you're more likely to see something like this, where you have binomials in your parentheses instead of just single numbers or monomials that just have a mixture of x's and numbers with no plus or minus. The rules don't change. We're still going to deal with your coefficients first, and minus still means move in the denominator. The only difference here is when you bring this 3 inside your parentheses, you're not really bringing it inside the parentheses, or we need to create new parentheses because this will be natural log of x plus 2 all cubed. You don't distribute that cubed to the x and to the plus 2. Same thing here. This squared, you create new parentheses to hold that 4x minus 7 together, and the 4x minus 7 as a whole is going to be squared. Now, if I wanted to write this as one logarithm, because they're added together, or they're all plus signs. That means they stay on the top of my fraction. So I will have x plus 2 all cubed and 4x minus 7 all squared. And this looks long and messy, but you will leave it like that. I have a few extra that you may want to practice before you get to your homework. So you may want to pause the video here and try these 3 problems. Here are the answers. For this first one, you move your 6 inside your parentheses, and then because this is a minus, it goes in the denominator. On top, both of these are pluses, so they stay on top of the fraction. You would multiply 3 times 2 together to get a 6. For the second one, bring your 2 inside your parentheses. You'll have to create some new parentheses, and bring your 3 here as an exponent. 2 cubed is 8. And then for the bottom, or the last one, bring your squared inside, your 4 inside, and anything that has a minus sign moves to the denominator. So 5 and 5x plus 1 to the 4th power stay on top, and 3 squared, which is a 9, is in the denominator.